I'm going to clap and then start.
Yeah.
Between two nerds.
Yeah, curiosity lab between two nerds. Welcome to Test Pilot episode 2 of Curiosity Labs Between Two Nerds, where we invite a small human being to come in and ask us pretty much any questions they like in the arena of science. And this week's small human being is...
Raafae Chandu. I'm 10 years old.
Very nice to meet you, Raafae. Thanks for coming.
Thank you.
Go!
So, let's go.
And you know the nerds, I'm Mo.
Yeah.
And I'm Eugene.
Okay.
So my first question is, how did the universe start?
Oh, jeez. Right from the beginning.
Blatantly
Yes,
asking
right
that
from the
question. He's looking at you. Who knows
We
where
can't
the
get
answer's
more
Yes.
to the start than that.
Yeah.
Right?
Yes.
Okay, so the universe started with something called the Big Bang.
Yes.
All right? It's as far back as we know.
Mm-hmm.
So basically what happened, right? As astronomers were looking at all the galaxies and the stars, they noticed that all galaxies, right, were actually moving away from us. Okay? So now, if all of them are moving away from us, so let's say if we forward it, let's say 1 billion years, then all the galaxies would be where?
Far apart, really far. Yeah.
1 billion years further away from us. Now, instead of that, let's rewind it 1 billion years.
Yeah.
What would the universe look like then?
1 billion years closer than it was. Billion
Yeah,
years.
so those galaxies, planets, whatever is out there, right?
Yeah.
Would be closer. And if we go another 1 billion years, closer.
Oh, so it must have all happened from one point when they were all...
Yeah, so if we rewind the clock far enough back, right?
Yeah.
There should be a point when all the galaxies and everything in the universe were just on top of each other.
Yeah.
Squeezed into, let's say, a tiny little dot. Okay? Now that, we'd have to rewind the clock about 14 billion years. Okay?
Which is ages.
It's actually 13.8 billion years if we're being technical.
Still ages.
Right?
Technical.
13.8 billion years. So what we assume is that the universe was way smaller and just confined in a little dot. Something happened 13.8 billion years ago.
Some sort of flash in there? Yeah.
Now we're talking about before time even began.
Yeah.
So everything that we know,
Yeah.
right, has sprung out from that one instant, and it's expanded to 13.8 billion years, and that's where we are now. But when we say everything began, it's also that's when space started, as in the space you move in. There was no space before that. There was no time before that, because as far as we know, time started at that instant. So to say, which I'm sure this might be one of your questions, what happened before the Big Bang actually doesn't make sense, because there was no time.
Yeah, my next question was actually going to be, where was that dot if there was no space?
Great question.
Yeah.
So because see, now the question itself, though, now this is getting very philosophical, right? Right from the start, we love it, right? The question itself, now this took when I've heard physicists talk about it, it took me ages to even like wrap my head around this.
Just grasp.
But there was to even ask where it was implies that there was a space, a place for it to be, but there was no such thing as a place yet.
Okay.
So you can't ask where it was, because everything space itself started at that instant, and even time started at that instant. So yeah.
So I guess there isn't really such thing as nothingness, because there's always got to be something there. Like in space, you could say it's nothingness and like voids and stuff, but it's just vacuum, right? But that's still something.
Yeah.
That dot would have still been in something.
It was
been a place.
Everything.
Yeah.
Okay. But even like the whole idea of there being nothing. I've been reading this book on quantum mechanics, which completely blows that away as well. But even in a vacuum, right? They may not be particles, but there are forces. So there's gravity in the vacuum. There are fields of forces. So the electric field, the magnetic field, it is in a vacuum.
Yeah.
So even the idea of this is already trippy. So even there's no such thing as nothing.
Yeah.
So we've already had no such thing as nothing, no time before the Big Bang,
And then no place.
no place before the Big Bang.
But if there's
And we're about
if
2
there's
minutes in.
no such thing as nothing, 14 billion years ago, there was nothing.
But there was no.
There was something. There was that.
Well,
I guess for you to say that there's nothing, there has to be something to begin with,
Relative to
matter.
nothing.
Relative to
Yeah.
what?
And
Right?
that matters what the universe is growing into right now, I guess.
Yeah, now that's another question that doesn't make sense, because if space
Yeah.
is created at the Big Bang,
Yeah.
so what is the Big Bang growing into does not make sense. Because
Yeah.
no, there's no into out there anything. You're talking about something that is existing outside
Yeah.
space as we know it, though. That's
Okay.
the main thing. We don't, obviously, no one was around,
Yeah.
right? So
I was
we
around.
don't know this
It
yet.
might have been.
Oh, good jokes.
Why did you ask me?
Yes. Yeah.
Yeah.
Another question?
What made me? I was there in a way.
Yeah. That,
Yeah.
So were you. So in that tiny thing that was in nothing, that we don't really know where it was because it wasn't anywhere,
Yeah.
that created everything.
Yeah.
Some of that everything that it created
Yeah.
is me and you.
That's true.
So you were there.
Yeah.
Yeah.
So
You
why
just
don't you
don't
know?
remember
Yeah.
it.
Yeah.
That is actually a great point there.
Yeah.
So everything, every atom,
Mhm.
not even atom, goes smaller. Every quark, every electron, everything was there in that instant,
Yeah.
in some form.
Yeah.
Okay.
I wouldn't have.
It wouldn't have been as.
You wouldn't have looked like that.
Yeah.
It wouldn't have been as matter, though, as something that occupies space and
Yeah.
weighs something. It
Mhm.
would have been as energy. So it's just pure dot of
Mhm.
unimaginable energy.
Yeah.
Sitting nowhere.
Yeah.
Yeah.
And in at no time, right?
Yeah.
Okay, so wow.
Honestly,
This is a great start for
It's like
episode
sci-fi
1.
books.
if we do this again in 200 years, we might have a better answer.
Yeah.
And you might have found it.
Yeah, and you might even be alive then. That's a whole other thing. Yeah.
Yeah.
That's
So,
let's not go there.
so, so there is energy, explosion,
Yeah.
and it was incredibly hot, obviously, right? This
Yeah,
big,
there's a lot of
massive
energy
explosion.
just-
Now, the scientists actually don't know. They start at there is a time that they
Mm-hmm.
start where they can actually now start predicting or not predicting, but the past.
Predicting.
Right. Okay, so they can start their assumptions from a certain point,
Yeah.
and it's something like 200 milliseconds
Yeah.
or something, right? Before that, though,
Yeah.
they don't. This is
Yeah,
all like
it's-
hypothetical.
yeah.
They were just guessing. here.
Yeah.
I'm not guessing, but there's a little bit informed guessing.
Educated guess.
Yeah.
Educated guess.
So there's energy, really hot. The universe is too hot. It's too hot for there to be matter yet. Stuff, as we
Yeah.
know it, atoms. And then energy cools down. As the universe cools down, now energy can condense into matter, like
Yeah.
how water, steam,
Yes.
right? You breathe onto a cool
Mhm.
piece of glass, and the water vapor in your breath cools and turns into liquid water, right? In the same way,
Yeah.
energy condensed into matter.
Yes. It was all condensed into that tiny dot, and then something happened, and then it just
Yeah, so
It's-
existed. So there's energy and matter are like
Yeah.
interchangeable.
Yeah.
That's what Einstein, that famous formula?
E equals mc squared.
Oh, there you go.
Energy equals mass times the speed of light squared.
Oh, look
Yeah,
at that.
thanks.
Yeah.
You can go home now.
Yeah, so what that tells us is that's just a way of relating the two,
Yeah.
right? So so you can take
Yeah.
energy and you can turn it into mass and
That's
matter,
just a way to
and then in like a
Yeah.
nuclear bomb, we take matter
and then turn
and then turn it
energy.
into energy.
Yeah.
Yeah.
So it's just yeah.
Yes, it's interchangeable. It's kind of the
Yes.
same thing. It's a different states of one.
Yeah.
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 But what did it explode into?
I got that. Yeah, so every atom, so I can't remember how many particles last time I counted.
Oh,
Oh
Human
yeah, last
body.
time you counted.
Okay, so
Loads. It's loads.
yeah, but what do you think came next? So we have energy, matter. First starts with matter. Let's say quarks and atoms, and then
probably. Well, if there was only energy and mass, there must have been elements sort of forming out of mass.
good, right? So so it has to be one element first.
Yes.
So elements are like the different types of atoms that exist in our universe, and it's like more than 100 now that can possibly exist.
Yeah.
Number one is
Begins with a H.
Is it high? No, I don't know.
yeah,
Go on, say with confidence.
yeah.
Is it? I know the word. I know the word.
Hi.
Hi, my name's Raafae. Hydrogen.
There you
Good
go.
job.
Hydrogen, exactly.
Yes.
Right. So because that's the simplest atom you can have.
Yeah.
So we have only hydrogen at a start.
It has like one electron. I'm pretty
Yeah, so one
Very good.
electron, one proton.
Yeah.
Right, now you have all this bunch of hydrogen now, but it's dispersed across how much of the universe is there at this moment in time.
Yeah.
What happens next?
I think other elements start forming that are a bit more advanced, have more.
Yeah, heavier, yeah. But for
Nice.
that, you can take it away.
Sorry, I was thinking, well, next got to be the dinosaurs.
so you got hydrogen.
And then dinosaurs.
Heat.
No.
Yeah, but how they come together? So you got one hydrogen atom here, one hydrogen atom somewhere.
The electrons change.
Why do they come together? Do you know why they come together?
Sorry, I thought you could run with this.
Okay, I was in a different space. What makes two things come together?
Gravity.
Very
Look at
good.
you. Yeah,
You can
good
get a
job.
high five for that.
Okay.
So, gravity starts pulling all this stuff that's everywhere
Together.
together into lots and lots of different things.
So they trade like electrons, so they become different matter.
Not yet.
But
we'll get
they
there.
have to pull together first.
Yeah.
So things, all the stuff, so all the stuff that exists in the universe in various forms, back to the energy conversation, is created,
Yes.
for want of a better way of putting it, or is suddenly apparent.
Yeah.
And then that stuff starts clumping into lumps and clouds,
Yeah.
big clouds, of various bits and bobs.
Yeah.
And then once you've got these big clouds of various bits and bobs, that's when
They start.
things start to change and things start to...
And that's like nowadays space clouds, like we.
Yeah, so you still have interstellar clouds, right? Mostly at that point there would be mostly hydrogen. I mean, almost, actually not mostly, only hydrogen. Sorry,
Yes.
and maybe some other subatomic particles. Gravity keeps pulling them together more, and they start to form into like this sphere. Now, if there's enough gravity, what's going to happen is it's just going to keep pulling things together.
Yeah.
Still all hydrogen,
Okay.
right?
Yes.
And it's going to squeeze it. All that gravity is going to act and squeeze these atoms closer and closer together.
Yeah.
And then we have a process called fusion,
Fusion.
where these atoms are so close together now they fuse and they form a heavier atom.
Okay.
So the first one that would form is after hydrogen.
After hydrogen.
You know number two? No? So it's helium.
Yes, I know.
Okay. Yeah. So anyway.
I have like this periodic table stuck to my head.
So it's helium. And the reason why it's called helium is because of Helios, right?
Yeah.
Helios, sun, right?
Yeah.
So forms into helium.
Yeah.
And that process, that nuclear fusion,
Yeah.
releases so much energy, and then you have your first stars start to shine.
Okay.
Pretty cool.
So actually, we just linked to my next question, which was
remarkable.
about the stars. How the elements started growing more complex, and how the white stars, how they grow big and they become white, and then they shrink and then they go brown.
Yeah, so there's like this whole life cycle of stars.
Dead Star.
Yeah. Like the Death Star.
My favourite star.
Yeah, so first you form helium, now stars are starting to shine for the first time.
Yeah.
Then after that, but then you take helium and it's still in there, right? In the center of a star, and maybe there's enough gravity for another hydrogen atom to join onto it. And now you're beginning to form the slightly heavier elements, but not even slightly. This is still number 3 and 4 on the list, right? Lithium. And then you slowly, so by this process, you get heavier elements. Now, I think in a star the size of our sun, you can't really get much heavier than carbon or nitrogen. Okay, but what happens is now stars aren't eternal. Like there is a day that they stop burning, because at a point what happens is they just run out of fuel. There's just not enough hydrogen to keep this nuclear fusion reaction going. So they run out of fuel, and as they run out of fuel, they start to expand first. And they go into it depends what it started off as, but ours will go into a red giant. Right? And I'm not too great with the whole life cycle. But then sometimes at a certain size of star actually would explode in a nova or supernova. And all of this stuff that was cooked up inside that star, these heavy atoms, right? Let's say carbon and nitrogen and even oxygen explodes across the universe.
Spewed.
Nice.
Now, but so there are generations. So our star, I think, is a second generation star. So they were the older stars first, and sometimes in those explosions as well, new elements can be formed in those explosions because of the crazy force. So even the heavy ones like iron and things like that, the metals get formed in exploding stars of supernova and above, and hypernova. And then this is spewed across the universe for this whole process to happen again, and another star to form. Right? So I think our sun is second generation, maybe. I think. I have only one documentary I've probably watched.
I know where it is.
So then the next star forms. Now around this though, now you have all of these other, so before we just had hydrogen floating around. Now you have different amounts of carbon and nitrogen and oxygen, and some of the heavier stuff as well, like iron and copper floating around for gravity to do its business again over billions of years and coalesce and join them up into another ball. Sometimes if there's enough hydrogen and stuff, it's a star. And if there isn't, then you may even get planets. Or it'll start smaller, let's say an asteroid. Or something like the size of the moon. And then now you have planets. And so your rocky planets, right? Terrestrial planets.
Very good.
Is it rocky?
I like rocky.
Okay. But then if there isn't enough hydrogen and all these other gases, right? If there's just not enough, instead of becoming a star, what it becomes is a gas giant. Like Jupiter. Which they thought was actually probably the biggest a planet can get before it becomes a star, but then they found one that's
much bigger.
3 something times bigger than Jupiter, just in the last few weeks.
Last few weeks?
Yeah, it's totally changed assumptions.
So, okay. So, wow.
It's not in our solar system.
So now moving closer to our planet.
I love it.
You're leading this.
Yeah. I love this. It's probably chronological.
When are we going to get to cats?
We're dinosaurs right now.
Dinosaurs. We're nowhere near the dinosaurs.
So our sun, just to give you an idea of where we are. So we started 13.8 billion years. The first stars, I don't know, dude. I don't know dates offhand. I wasn't there, obviously. Although I was.
Sort of.
So basically, an offshoot of this, by the way, which is an amazing fact to know, that so the atom, so your body, right, is mainly carbon, nitrogen, oxygen with some iron thrown in there, hydrogen as well, some iron thrown in there, and calcium, and all of those atoms were cooked up inside a star billions of years ago, and then that star vomited all out as it exploded. So you are actually made, if I want to say poetically, star stuff,
Star
To be honest, that's
So is that
Carl
poetic?
Sagan.
Star stuff. Star dust.
Stardust, yeah, that's what I was going
More
Carl
poetic.
Sagan, yeah. The Carl Sagan quote came in my head. So stardust, that's poetic. Star stuff, which is like Carl Sagan said. Or less poetic, way less, star vomit.
Wow.
Yeah, or shrapnel.
Yeah.
All right. So that's what you're made out of now. So you have a special place in the universe.
Yeah.
You are very much a part of
Yes.
this universe, right?
Yeah.
And but not to make it less special, so is everything here. So the wood, right, and this table, again, carbon, hydrogen, oxygen was cooked up billions of years ago
Yeah.
in a star.
Wow.
Right.
So everything just came from that tiny dot. Then there was stars
Yeah,
from
and then
hydrogen.
Lots of stuff happened. Yeah,
Lots of stuff.
Yeah.
I love that stuff. Lots of stuff happened.
basically. Yeah, so then so 13.8 billion years, Big Bang, about, I'm guessing 10 to 12 billion years ago, first stars.
Mm-hmm.
Our star, I think, is about 5 billion years
Okay.
old. The Earth and the other planets are around 4.5 billion years.
Okay, so the sun was around
Just a little bit.
half a
longer.
billion
Yeah,
years.
because you needed the sun's
Yeah.
gravity to pull
all the
all the other dust in.
So without gravity,
yeah.
Oh,
the universe would just be a cloud of hydrogen floating off
Yeah.
apart away from each other.
Yeah.
expansive, like waste.
Yeah.
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 So
Okay.
it orders the universe.
Thanks,
Yeah.
gravity.
So this is way before any sort of civilization. Way
yeah.
before. So
I mean,
when was
as far as we know. Maybe on another planet somewhere. Don't worry about that.
yeah, we'll get to that.
Yeah.
The first sort of living creatures, what do you
Yeah.
think was maybe like, which sort of,
So, first living things.
was it dinosaurs or was it?
No.
It was,
It depends what you do. So if you're asking what the first living creature was, that's a very different question to
first living
first
animal.
life,
First life,
Yeah.
okay.
the mystery of
Yeah.
first life on Earth.
So it might be like a plant or something.
So I think what they think so far, as far as the first thing was the first type of life was like like a molecule, like a chemical molecule that could make copies of itself, like DNA.
Okay.
So it's like an ancestor of DNA, basically, which we think we call like RNA, right?
Okay.
Then this DNA molecule started to form a protective, like skin around it.
Membrane, yeah.
Yeah, okay, you're just making it a little bit more accessible, right? Like a skin around it.
Yes.
So
To keep it
so
all.
then that would be like your nucleus, and then they thought, oh, you know what would be better? Like, oh, if you had another protective like skin around it, and then you have your cell. Now you have basically
Cells.
actually you shouldn't start a nucleus because that came way later. So your first cell wouldn't be with the nucleus. So so that would be the first sign of life, and I think it's like around 4
It's pretty soon. It's early.
billion
Yeah.
years. Yeah. So so pretty much as soon as they could be life on a young Earth, there was life.
Okay.
So about 4 billion years.
Okay. And then obviously there were plants, right? That would
Still, this is multicellular. So
Yeah.
from those early types of microbes,
molecules,
like let's say,
microbes.
microbes. Then one of the most important things that happened was that one of these microbial cells, I'll call them, swallowed another one,
Yeah.
right? So there's one that was really good at producing energy, and there's one that was larger.
Yeah.
And one of these swallowed up the other one,
Okay.
and then instead of just digesting it, they learned to live together.
Oh, okay.
So this one had this protective cell around it, right? And then the benefit for the bigger one was that this was really good at making energy.
Yeah.
So it was just like a good little symbiotic partnership.
yeah, okay.
Okay. And now cells can get much larger, can do more things. And you had your first type of cells that all the bigger living things are made out of, like the plant and you. So we call these eukaryotic cells, if you want to know.
Eukaryotic.
Then there's prokaryotes with the bigger ones, older ones.
Eukaryotic cells.
Yeah, eukaryotic cells.
I'm not.
So you have these cells, and then now they can do much more functions, and now you can start and have lots more energy, and now you can have all the basic powers, let's say, are there to support much larger, complicated life forms.
Yeah.
And then Eugene's really the expert on
Dinosaurs.
the fossil,
Dinosaurs are...
the history of multicellular life.
There was loads of life.
Yeah.
Loads of life. Big animals, little animals, creatures in the sea, tiny animals, plants, for millions and millions and millions and millions of years before the dinosaurs.
Yeah.
So all the dinosaurs are a type of reptile. So reptiles have been around in all sorts of forms. So crocodiles have been around way, way earlier than the dinosaurs. So then
sharks
are way, way older. So the first dinosaurs really sort of 250 million years ago. But huge life is on planet Earth hundreds of millions of years before that. So do you know the ammonites? It's a classic fossil. It's a sea creature. It's like a shelled squid is the best way to describe it. And it looks like a big snail shell. So they were around with trilobites and another big sort of armoured sea creature 450 million years ago and dominating the planet. So the dinosaurs only evolved as a new species of reptile 250 million years ago. And while the planet looked very different, it was full of life and full of big life, big creatures. So if you went there, clicked your fingers, magicked your way back to Pangaea, which is all the Earth, all the land was stuck together 250 million years ago. So if you went there before the dinosaurs, you'd recognise a number of creatures. They might be freakishly large.
That's like insects were like way, way bigger back then because there was way more oxygen in the air.
Okay, so they
were like giant,
which weirdly is kind of because trees hadn't evolved.
Yeah.
Okay, so
because trees hadn't evolved, this is a tough one. But bugs, so dragonflies and things, insects that we see flying around, were vastly larger, sort of your size, my size even, flying around. My size even, I'm not that big. And the reason for that was this. The air was what we would call now over-oxygenated. So they were able, because of the way that they absorb oxygen, they were able to get supermassive for an insect. And then with the evolution, when plants evolved into trees, it was to do with, and I'm not brilliant at this, but the trees would die, and the stuff, this is a tree, this is a dead tree, so they would die. And when they would die, what now eats away all that carbon and that energy in that tree hadn't evolved. So kind of bacteria and the stuff that would decompose that tree hadn't evolved. And that changed because we had loads and loads of dead trees. That changed the composition of oxygen in the air, which meant the bugs got smaller. But the dinosaurs got bigger. Yum, yum.
Because they, most of them depend on the trees,
Well, so you have the plant eaters. So it was like an arms race. So, and you're talking a crazy scale of time. So if you think the first dinosaurs, if we're just going to look at those, were 250 million years ago. And the last dinosaurs were 66 million years ago. So you've got 190 odd million years of dinosaurs. Now, we as humans have been around in various forms for maybe 2 million. So all of our history is that compared to this vast amount of time that the dinosaurs were around. So they had time and time and time to evolve. So just the Tyrannosaurus or the Tyrannosaurs, they were around for 100 million years. Well, the Tyrannosaurs is a genus of dinosaur. So they were around, just that arm of dinosaurs was around for 100 million years. So that arms race to grow, to survive, to evolve, had a huge amount of time to kind of achieve what it achieved. But they died repeatedly. There were mass extinctions over that period of time.
5 so far, and we're in the 6th.
There's been 5, we're in the 6th. And if you just take the dinosaurs, the period the dinosaurs were alive, they started with a mass extinction.
Okay.
Then there was another mass extinction at the end of the. So you've got, get this right. It goes Jurassic, Cretaceous, Triassic. So the end of the Triassic, which is the first third. Well, not quite, but let's call it the first third of the dinosaurs living. Most things died.
Oh, okay.
Then, which allowed other creatures to get supermassive. So, say the Stegosaurus. Have you heard? Do you know the Stegosaurus?
Yes.
Lots and lots of people know the Stegosaurus. By the time the Tyrannosaurus Rex had evolved, the Stegosaurus was already a fossil. So you've got these massive periods. They weren't all rocking around at the same time.
Stegosaurus didn't need to worry about.
Stegosaurus never worried about Tyrannosaurus Rex. It might have met some tyrannosaurs, some early tyrannosaurs.
From the gene pool.
From that genus that became the Tyrannosaurus. So they started becoming what we would call a tyrannosaur about the time that the Stegosaurus was around. But it never would have met a T-Rex.
Oh, right.
That was way later. So it's just crazy long periods of time.
Okay.
Because like the mass extinction for the 65 million, they only like wiped out 75%, I think it is.
Of life.
Of life on Earth.
That's the reason we're here.
Yeah.
All right.
So as mammals.
Open up a niche.
Yeah. So it's if you're a tiny little mammal.
Yeah.
And remember, this is not overnight, and you've got tens of millions of years to evolve. But if all of a sudden all the major creatures in your ecosystem and potentially in your food chain, but it doesn't even have to be in your food chain, are wiped out, you're welcome to the land of opportunity. So those creatures have the opportunity now to evolve and develop and adapt and take on new areas and new species within themselves.
It's kind of like Home Alone in a way. So here's
is it?
So you have what's his name? Kevin Macaulay Culkin.
Yeah,
right.
Kevin.
Everyone in his house leaves. You know, he's all like he has to live in his little room and always bullied and like has to stay. See, you can see where this is going. Right?
Are we gonna get sued for this?
And then everyone else leaves. Right. It goes extinct, and now he can just be himself and goes out. Buys food, shaves, and can like live his life the way he wants to. Yeah. So it opens up this opportunity. These extinctions always open up these opportunities, and they've been like. So the one that killed off the dinosaurs wasn't even was a pretty bad extinction.
Oh, it was a bad one. Certainly for the dinosaurs.
But then there've been ones before that where like 90% of life has been wiped off there.
Nearly all life. It's amazing.
It's always because, except for the dinosaurs, it was always because of big changes in the climate. Yeah. Which is why we are currently living in the sixth mass extinction. Yeah. Right? And again, it's because of, humans, obviously. Yes. Humans.
Yeah, this one's odd. So a normal mass extinction, I wasn't there. But what we term those mass extinctions, it's important to remember that they're not overnight events. So when we talk about climate change at the start of the Triassic period, which is 250 million years ago, you're not talking all of a sudden or over 10 years it's gone crazy hot or crazy cold. It's
that wasn't
hundreds of thousands and probably millions of years of change in the climate. Yeah. Then you've got the end of the dinosaurs and the big asteroid. So that kind of was an overnighter. No, not everything died instantaneously, but it was very, very quick in terms of the scale of things. And now the one that we are witnessing now is, while it's not because of an asteroid, our humans' impact on the planet means that it's happening in crazy, crazy fast forward compared to 4 out of 5 of the previous mass extinctions.
Our effects on the world are way more. They actually affect it way more than what it was before when.
Our effects are so that if you take, the one that's talked about most is climate change, which is kind of. Okay, fair enough. And that is accelerating and it is bad.
Very bad.
And it will cause that mass extinction. But the other impacts humans have, so as long as humans have existed, we kill stuff. So take the mammoth, the woolly mammoth. It wasn't climate change that necessarily killed the woolly mammoth. It was humans killing the woolly mammoth that killed it. And there's some amazing creatures that lived on planet Earth really not that long ago. So, and we call them megafauna, and they're massive, awesome creatures. And all the megafauna is gone.
Yeah.
Not because of climate change, but because humans, to people on paleo diets that think they're tree hugging and amazing. Well, those people, sorry, but those people,
like new friends, are we?
But those human beings were responsible for killing all the animals within their ecosystem. So, and we take the land away. So the mass extinction, and there's some crazy stats out there, like 1 million species are going extinct a month, let's say. I think it's shorter than that.
Million?
Of life,
like 1,000.
No, it's crazy numbers. Double check that. Double check. Because
it's a lot.
Do not
It
trust.
might not be as crazy as that number. I think it could be, though. Or there's 1 million gone extinct in our living memory.
Yeah.
They're not going extinct because of the headline of climate change. They're going extinct because if you look out that window, it's no longer a desert. If you go to London, it's no longer a forest. We're totally changing the ecosystems and landscapes.
Yeah.
Sad. Right?
Very sad.
Very sad.
I mean, it's just, we just have to be more responsive. Not that in the past, we just didn't know.
Mm-hmm.
And now we know better.
Oh, there's hilarious. It wasn't hilarious at the time for the humans that did it, but history has shown us that that ignorance. So at some point, someone who survived, some group of humans that lived on mammoth meat.
Yes.
And every day they'd be killing mammoths, and everything was wonderful. It never occurred to them that at some point they're going to kill the last mammoth and they're going to starve.
Yeah.
So they just keep doing it because they're ignorant of the impact they're having.
Yeah.
There's an island that was inhabited by humans for thousands and thousands of years. And it relied on this bird population that came in. This is thousands of years ago. No, it's not thousands of years ago, but it's hundreds of years ago. And it relied on these birds, these migratory birds that came over, and they would eat the eggs and they would eat the birds, and it was amazing. And so they'd have this big harvest at the time of the year when the birds came in. But they also loved to chop down the trees and use the wood and become more civilized on this. It's like a tiny micro example of planet Earth.
Yeah.
And there was a day where they decided to chop the last tree down. Because that had to happen. There had to be a day where there was one tree left. And they're scratching their heads and they're thinking, well, maybe we should leave it up because the birds we know like those trees, but I really want to build a new house. So someone's chopped that last tree down. The birds no longer came back and that civilization collapsed and died. And it's its own fault. It just killed itself.
And everybody died in the end.
Ultimately,
but the thing about this climate change thing is we should be more worried selfishly because it's the planet will be there. There's nothing we're going to do that's going to destroy the planet. It just will not probably have human life on it if we keep at it.
It's not like we are doing it to the planet, but then we're doing it back to ourselves.
Yeah, exactly.
It's like karma.
So
your own house down.
So it's like we're saying we're destroying the planet. No. It'll bounce back. Even in a few more million years, it'll be fine. There'll be new life here doing everything. Humans, however,
you might get new set of dinosaurs.
Wow.
and then it's like the circle of life.
But we won't be here to talk about it.
So we've gone 13.8 billion years in the past, all the way to present day, a little bit into the future.
Mm-hmm. I think we skipped a very big period.
Oh, did we? Sorry. We may have glossed over.
We can't do it year by year.
We may have glossed over a couple.
The Iron Age, the Bronze Age.
Oh, yeah.
How the human civilization sort of started. I think we covered it a tiny bit, but how it sort of started getting into the.
It's more history.
There's my suggestion is we'd save that for another conversation.
That's a whole.
But as an interesting thing on that, there's a group of chimpanzees that have been monitored for decades, and scientists have been monitoring these chimpanzees, and they officially think now that if you monitor this particular, not all chimpanzees, but this particular tribe of chimpanzees, that they are entering the Stone Age. So they are developing their use of tools to the extent that when we look back at human history and we describe the Stone Age, which is when humans started picking up rocks and turning them into tools, as that step one on our path to be sitting here, there's a group of chimpanzees that, as from a scientific perspective, you would say have just entered their own Stone Age. So maybe if they survive all this climate change,
Planet of the Apes.
Planet of the Apes will be here in a million years or so. Which will be excellent. I won't be here. We can imagine.
So,
any
questions? I don't know how to end this.
You've got to edit this.
We'll edit that.
Did you enjoy that?
Yes, I did.
Did you?
Yes, I did.
We might have you back.
So we'll save the history of human civilization for another chat. I'd love to have you back. Right? But I think we've covered quite a span of time in the last few minutes. So it was pretty good.
You kept us in check, so thank you for that.
13.8 billion years ticked off the list. Right? We'll look closely at the last 2 million. No.
We did skip 200 milliseconds at the start there.
Yeah. And the last 200,000 years of Homo sapien, we can cover that another chat. But
we'll go further back. We'll go 2 million years.
Oh, God,
for human history.
You have fun?
Yes, I did.
Yes.
Thank you so
Learned a few cool facts?
Yes.
Yeah, I did.
All right, thank you, Raafae.
Thank
You were
you.
awesome.
Thank you.
And thank you guys for listening or watching.
Bye.
Wave.
Thanks, Mum.
Wave.